Hi algebra students, please grab your chapter 9 mixture/investment problems notes template. We've talked about mixture and investment problems before when we were writing and solving equations with just one variable. Today we're going to talk about it if you wanted to write it in terms of a system of equations, so meaning two equations with two variables. So if you take a look at the first problem, it says students working at a refreshment stand mixed cranberry juice at 50 cents per liter. So we're going to fill in for the value 50 cents for cranberry juice. And I'm going to leave my cents in integers instead of writing a decimal, but you could also be uniform and make sure that you use that as 0.50. And apple juice at 35 cents per liter. And they combine that to make a fruit drink that is worth 40 cents per liter, and we have 120 liters of it. And we want to know how many liters of each did they use. So there's two unknowns here. We want to know how much cranberry juice they added and how much apple juice they added, and we don't know either of those. So we're going to use them as x and y. But if you can remember back when we first looked at problems like this, we probably would have set it up as x, 120 minus x, and 120. And I can't speak for all algebra students, but remembering to set up this subtraction problem was kind of difficult for them. So it's kind of nice to set it up with two variables and not have to worry about setting it up as a subtraction problem. Just like we did with our other table value word problems, we're going to multiply across. So I'm taking the amount times the value of 1 to get a combo of 50x here. This would give me 35y, and 120 times 40 would give me 4,800. Now what you want to do is you want to think about what two equations you can combine out of this table to get your system. And the first one, just like in the last unit, is going to come from this last column, where we are going to add 50x to the 35y and set it equal to the 4,800. So that's equation 1. Now if you look at this middle column, there's really not anything we can write an equation with here because there's no variables. So we've got to be using the first column, which talks about amount. So my second equation would be x plus y equals 120. And that's my system of equations. Now I want to figure out what method of solving should I use in order to solve this system. And probably the easiest one here would be to do elimination, or I'm sorry, substitution, where we solve this bottom one for one of the variables. So I'm going to move the x over, which means I can rewrite that as y equals the opposite of x plus 120. Then I'm going to substitute in this for y in my top equation. So that's my plug-in, and I want you to go ahead and solve that for x. So you should be finding an x value of 40, which means you're halfway to the solution. You need to also find the y value, and the easiest way to do that would be to use the second equation from your system, substitute 40 in for x, and solve for y. So y should be equal to 80. The last step I want you to do, part of the 5-step process, is I want you to go back to the original problem and see what they're asking for. They want to know how many liters of each did they use. So in your sentence, you need to use units of liters, and you need to identify how much of each type. So let's write a sentence something like, they used 40 liters of cranberry and 80 liters of apple. Okay, so take a look at number 2. How many liters of water must be added to 20 liters of a 75% acid solution to produce a solution that is 15% acid? The first thing I probably want to do, because it's a little bit easier for me to pick out, is I want to fill in the percents of acid that I see in my table. So I want to fill in 75% acid to the original, and I'm going to write that as a decimal, 0.75. We are creating a new solution that is 15% acid, so that's going to go down here. Now I want to know how many liters must be added to 20 liters. 20 liters is the original amount of my original solution. So I don't have any variables in the top row. And when I multiply these, the amount times the percent acid, it's going to give me a total acidity of 15. I want to know how many liters of water must be added. So I don't know how much water. And this is 0% acid. When you multiply x by 0, the x cancels out. So we really just have 0 for total acidity. I'm creating a new solution. I don't know how much, so that's going to be y. And I'm multiplying it by the 0.15. So my total acidity there would be 0.15 times y. So my two equations for my system of equations are going to come from the last column here. So I'm going to write that as 15 plus 0 equals 0.15 y. And then my second equation is going to come from the amount column. 20 plus x equals y. Now if you notice, the top equation does not have two variables, it just has one. So we can quickly solve that for y, get half of our solution, and use it to plug in. So this gives me, this is the same as 0.15 y equal to 15. I'm just kind of doing a sim e there and cleaning up the plus 0. I'm dividing by 0.15 to both sides, so y should equal 100. Then I'm going to replace 100 for y in the second equation. Solving for x, x should be 80. Now if you go back to the original problem, it just wants to know how many liters of water. So I'm not really interested in the y value that I found. I'm only interested in the 80. So I want to write a sentence something like 80 liters of water must be added. So anytime you look at a situation where one of the variables falls out of one of the equations, you really don't have to do much work there. You just have to solve for the remaining variable and then plug and chug into the other. Taking a look at number 3, we've got Kathleen investing $5,000. So that's her total amount invested. Some at 6%, the other at 5%. We're going to write those as decimals. So I'm going to have 0.05 for 5% and 0.06 for 6%. I don't need this square. We don't know how much of each she invests, so we're going to call one x and the other y. Then multiplying across in our last column, we're going to have 0.05x and 0.06y. And it tells us that she earns $280. And remember, that doesn't mean what's sitting in her account after the year. It means the extra money she earns from the interest. Our two inequalities here are going to be from the last column and the first column. So I've got x plus y equals $5,000, and I've got 0.05x plus 0.06y equal to 280. Now you could do elimination for this, but I think most students go with substitution. So I'm going to solve the top one for x, and that means that x equals 5,000 minus y, and I'm going to replace that in the second equation. Go ahead and do that and solve for y, or x, pardon me. So I'm finding that the amount that I invested, or that she invested at 6% is $3,000. And all I need to do is to plug that back into the original equation to solve for x. So x should be $2,000. And we want both of those, so we're going to write a sentence something like $2,000 at 5% and $3,000 at 6% must be invested. Make sure that you bring these completed notes into class and that you're asking your math teacher any questions that you have on them. And when you encounter a mixture or investment word problem on the Keystone, you can set it up as a system of equations like we've done today, or you can set it up in the old way as one equation in terms of just one variable.